Welcome to this explainer. Today we're taking a hammer to the whole AI neo-god myth and looking at what's actually happening down in the silicon. We constantly see headlines screaming about how artificial intelligence is going to entirely replace the human mind, making it sound totally inevitable. But when you peel back the marketing and look at the bare metal architecture of computation, a wildly different story pops up. It's one where you, the human, are actually the undisputed center of the entire operation. So, how do we get so tricked by the illusion in the first place? Let's get into it.
This right here is basically the core anxiety of our time, right? Are these massive neural networks generating genuine, original thought? Or are they literally just a really fancy digital kaleidoscope reflecting our own data back at us? When you see an algorithm spit out a hyper-realistic image in 2 seconds or write flawless code, it's totally natural to feel that pit in your stomach, that fear that human creativity is obsolete. But to really get what's going on, we have to ignore the shiny interfaces and dive into the actual hardware.
Section 1. The AI Creator Myth. To break this illusion, we've got to completely rethink our whole modern idea of the solitary romantic genius.
Here's the thing. True authorship demands biological friction. It needs emotional resonance, and what copyright law actually calls the sweat of the brow. Cold silicon just doesn't have sweat glands, The philosopher Hannah Arendt talked about this concept of praxis, basically an active, engaged doing tied to actual lived human experience. And AI doesn't feel joy. It doesn't grieve. It faces literally zero biological friction when generating text. Real art comes from a deep internal drive to express something, and machines fundamentally lack that human experience. Without that friction, there's just no real intent behind the output.
So if it's not a creator, what is it? Well, cultural theorist Roland Barthes nailed it with the term scripter. Think of the AI as a cosmic babblefish. It blindly maps your English prompt to these massive mathematical vectors and spits out something completely different, like Python code, without actually understanding a single word of either language. It ingests text, crunches the math, and boom, output. It's a wildly sophisticated vessel, pulling off a pure gesture of inscription, but it completely lacks the capacity to get your jokes or actually mean what it says.
Moving to Section 2, the gambler versus the surveyor. Since the AI isn't some magical creator, we need to look at the physical hardware running the code. And there is a fascinating divide deep inside your machine's brain. It is honestly mind-blowing when you realize that 80 to 90% of the heavy computing cycles powering these massive AI models are literally just probabilistic approximations. Seriously, they are not doing exact math. At the hardware level, they are making highly educated guesses, basically rolling microscopic dice just so they can crunch oceans of continuous data at lightning speed.
And this perfectly captures the split. AI leans incredibly hard on the FPU, the floating point unit, which is basically a super fast but chaotic gambler. This gambler relies on secret proprietary seed tables burned right into the silicon, frantically throwing darts at a dartboard to approximate math. But that causes a wood chipper effect, a non-deterministic drift that permanently shreds the original data's provenance. On the other side of the ring, you have the ALU, the arithmetic logic unit. The ALU is our exact surveyor. It deals strictly in absolute truth. 1 + 1 is exactly 2, every single time, on every computer on Earth. It acts as a globally accountable witness.
So how do we force this messy, gambling AI to play by the ALU's strict rules without grinding everything to a halt? Developers use an absolutely brilliant 3-step protocol called LLM42. Think of it like a digital wash cycle built to scrub out all that microscopic rounding gunk. It's called the DVR framework. Decode, verify, rollback. It lets us pull perfect precision right out of chaos. First, the FPU gambler makes a rapid, speculative guess. Then, it's strictly verified against fixed deterministic schedules. And if that floating point drift corrupted the data even a little bit, boom! It forcibly rolls back and recomputes.
Which brings us to Section 3, the pink elephant paradox. Because look, even with those genius hardware fixes, we still have a massive communication gap between human meaning and machine execution, and bridging that gap gets a bit scary. Take Anthropic's recent research on their Claude model, for example. They use something called a Jacobian lens, basically a mathematical magnifying glass to peek inside the AI's black box. And they found this hidden internal workspace. They dubbed it J-space. It's this wild, emergent area where the AI basically holds unspoken concepts and does silent reasoning before you ever see an output. But here is the major catch. They notice the model is actually terrible at suppressing thoughts within the space. Because neural vector space is inherently connectionist and super messy, telling the system to avoid a topic is a total trap. It's the pink elephant paradox. If I tell you right now, do not think of a pink elephant, what did you just do? You pictured a pink elephant. The AI does the exact same thing, just mathematically. When you issue a negative constraint, you accidentally highlight those precise vectors in its associative memory, and sure enough, that forbidden concept will almost certainly hallucinate its way right into the live output.
Now this is where it becomes a massive real-world problem. When the AI ignores those negative constraints and corrupts a system state, you can't sue the machine. The law doesn't work that way. The legal burden falls entirely on you. If you tell the AI to do something and it hallucinates bad data, makes a terrible financial trade, or violates copyright, the law sees that as an agentic tort. And who committed it? The human pilot who failed to properly intervene.
Tech scholar Madeleine Claire-Leich coined a term for this that is as brilliant as it is terrifying: moral crumple zones. She noted that developers intentionally keep human operators in the loop of complex AI systems specifically to act as these zones. Think about a physical car. The crumple zone is designed to violently crush on impact to save the cabin, right? Well, in these systems, you are the crumple zone. You're positioned there to absorb the legal and financial blow of the algorithm's screw-ups. Sure, you get the credit when it works perfectly, but you are literally the human shield for the machine's hallucinations.
All right, Section 4, LIFO and Absolute Truth. If we don't want to spend our lives acting as human crash dummies for algorithms, we have to ditch the probabilistic guessing. We need to engineer mathematically pure root-to-leaf architectures. Luckily, a framework called the ERC 7827 protocol is tackling this by pivoting to a LIFO architecture. LIFO just means last in, first out. By using a LIFO JSON state tree, which basically just structures standard JSON text perfectly, we can recreate the absolute tamper-proof security of an ancient clay seal, but digitally. This is not just some tiny technical update, it's a massive paradigm shift. It transforms right-weight JSON into a rigid mathematical layer that flawlessly tracks every single state transition, completely bypassing that messy floating-point guesswork. A great way to picture LIFO is like an incredibly strict bouncer at an exclusive club who only checks the ID of the person standing directly in front of him. The system only ever needs to query this one topmost point called index 0. It doesn't care about the 100 people way back in the line. By verifying just that very first ID at index 0, the system establishes absolute mathematical truth in an instant without getting bogged down by past data. And by locking the math down at index 0, we unlock something amazing: highly efficient, single-entry bookkeeping. This gives us immediate, mathematically flawless proof of reality. You completely skip the agonizing, expensive process of scanning huge transaction histories just to figure out what's going on right now. There's zero ambiguity, no probabilities, no educated guesses. It is literally either mathematically true or it isn't. End of story.
Finally, Section 5, the algorithmic orchestrator. This hard line between human strategy and mathematical machine action is totally rewriting what it means to be an author today. We aren't just staring at blank pages anymore.
True creation today absolutely demands that you apply your human protortion to actively reject the machine's distortion. This is what makes you the sovereign pilot. Let's lock these terms in really quick. Distortion? That's the lossy, chaotic guesswork of the machine. Protortion? That is your proactive, sweating, highly specific human intent. If you don't use your protortion to forcefully reject the algorithm's distortion, well, you fall right back into being that moral crumple zone.
So we have to cross what we call the semiotic bridge, the gap between our warm, fluid human thought and cold, rigid silicon. Step 1 is our abstract human intent. That's your messy, brilliant, associative mind. Step 2 is the divine script, using structured deterministic formats like JSON to lock that beautiful intent into a rigid template. And step 3 is ALU execution, where the silicon processes that exact voltage with perfect fidelity. The machine is just providing the technical muscle, but you are providing the soul.
So we've totally stripped away the magic trick to show you the hard wiring underneath. And it leaves us all with one final critical question. Are you going to passively sit back and absorb the machine's failures? Or are you going to step up, seize the divine script, and become the sovereign algorithmic orchestrator of your own legacy? The true magic of authorship is and always will be entirely up to you. Thanks so much for hanging out with me for this explainer, and I'll catch you in the next one.